Bismillahirrahmanirrahim. Alhamdulillahirabbil wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Assalamualaikum warahmatullahi wabarakatuh and good morning everyone.
Waalaikumsalam, Madam. Good morning.
Okay, so this is week number this is week number 4 actually. So actually in week number 4 we should cover new moment distribution method for frame. Okay, as I promised, I have actually made YouTube video for beam with support settlement analysis. I hope you will take some time to watch that recording because summative 1.2 will be given based on that one. Okay, so today I will move to frame analysis. Okay, frame analysis, and of course for one week session is not enough to cover all frame analysis. Okay, of course I will have another live lecture session to cover all that you need to know under frame analysis for you to get prepared for summative 1.3. So in topic number 1, moment distribution method, you have to do assignment for 30%. So as I mentioned previously, so this 30% is divided into 3, including summative 1.1, 5%, summative 1.2, 1.2 is 10%, and summative 1.3 covers frame analysis about 15%. So total is 30% your coursework. Okay, your coursework. And there will be another 10%, coursework will come from a flexibility method and stiffness method. Okay, so let's move directly to frame analysis. Okay, so basically under frame analysis we still need to calculate a stiffness factor. We have to calculate distribution factor. From stiffness factor we have to apply carryover. Careful with carryover because end condition. End condition, whether it is pin support or fixed support, we influence the result, the moment in the table. Okay, the carryover factor for N fixed is 0.5, for N pin or roller is 0. Okay, so under moment distribution method for frame, it will cover no sidesway frame, and sidesway frame. Okay, definition, how to identify between between the frame is sidesway or non-sidesway actually has been explained under chapter 11 in the textbook under slope deflection method topic. So please refer that to understand more about how to differentiate between frame with and without sidesway. Okay, this is the general principle, same like what we have done in beam. Okay, in beam where we need to distribute moment, and the moment that we distribute is actually joint moment, and joint moment is always opposite with member and moment. So one thing that is important for you to apply is, you have to careful with fixed end moment, because fixed end moment is the first member end moment in the table, and normally and actually we can apply fixed end moment by considering both end fixed for all cases, including beam or frame with end pin or roller. But we have to apply the right concept. Okay, like what I have explained in last week. Okay, in my video last week. Okay. Okay, again, for the sign convention, in moment distribution method, the clockwise moment, this is the assumption for that we apply at the beginning of the process. Okay, at the beginning. We have to we have to assume that a clockwise moment that act on member are considered positive. And finally, after we have done moment distribution, so the moment that we get, the sign that we get in the table is actually the real one. Okay, but the first assumption must be made clockwise moment act on member is positive. So join moment will be negative. Join moment is always opposite. So just remember that between join moment and member and moment opposite. That is why whenever you distribute, you have to change sign because of opposite condition of member and moment. Okay. Okay, this again, this is fixed end moment, so we have to apply this even though this is beam fixed end moment for beam both end fixed, so we can apply to all beam and frame analysis. Okay, in moment distribution method. So actually there are two column here. One the first column is for the first column is for both end fixed, both end fixed, or we call it as far end fixed, far end fixed. Far and fix. Far and fix. Okay, far and fix. Okay, the second column is for far and roller or pin, same. Okay, far end. Why we call it as far end? We don't need to call the first one as both and fix. Okay, because internal is always assumed fixed. Internal is always assumed fixed. So that is why for the second column, we call it as far end roller. Because internal, this is covering internal support. Okay, same goes to the first column. We just identify the condition based on N. For example, if we have A, B, C, D, and far N refers to A and refers to D. B and C are internal support. Okay, so basically, you will only use this one, okay, this UDL, and then triangular load, the common one, triangular load, and lastly is this lah. This is due to support settlement delta here. Okay, delta. Okay, for the member stiffness factor, this is just revision. So we use 4EI over L for N fixed, far N fixed. Again, we use the term far N fixed because another N is always located uh, as internal. Okay, as internal support. That is why we call it as far N fixed. And for N roller and pin, we use 3EI over L. 3EI over L. Okay, and we calculate distribution factor. From this formula, it is K divided by total K. K divided by total K. K is member stiffness divided by joint stiffness. Okay, so the procedure, okay, we move fast. Okay, moment distribution method for non-sway frame. For non-sway frame, okay, this is the example. This is the example for non-sway frame. Non-sway frame. So here, determine internal moment. Internal moment is member and moment. If you have question, you can ask. Okay, you can ask at any time. Okay, this example is taken from the textbook. As I mentioned, all example, concept, notes from this. Okay, is actually the summary of what you can find in the textbook. Okay, so determine internal moment. Internal moment means member and moment at joint of the frame as shown. There is a pin at E. So E is pin. E and D, jap. Pin at E and D. Pin at E and D. Fix at A. So fix at A. Okay, fix at A. Okay, EI is constant. EI is constant. So, okay, we go through this first. Okay, quite fast because after this we want to move to Sidesway frame analysis. Okay, so we have AB. AB we use, what is the formula for K that we use for AB? AB?
4EI.
Okay, here we use 4EI over L. Okay, what about BC? BC?
4EI over L.
4EI over L. Okay, what about CE?
3EI over L.
3EI over L. Okay, over L. What about CD?
3EI over L.
Yes, 3EI over L. Okay, so we have four members. We have four members. So we calculate as usual, and then we combine to get distribution factor. So remember that distribution factor for n pin. Okay, for n pin distribution factor, this one is must equal to 1. Distribution factor at E must equal to 1. Okay, distribution factor at A equal to at A
0.
0. Okay, and distribution factor for B is equal to total. B total equal to this equal to 1. Total. Okay, each joint equal to 1 distribution factor except n fixed. Okay, but B has combination 2 of 2 distribution factor, DFBA and DFBC. Combination of DFBA plus DFBC must equal to 1. Okay, what about distribution factor at C? Distribution factor at C, what should be the value? What should be the value? Distribution factor at C. What should be the value? Total. Distribution factor. Distribution factor at joint must equal to 1. Joint C. Joint B is equal to 1. Joint C?
1.
1 as well. Okay, 1 as well means that we can conclude that distribution factor must equal to 1 at each joint. At each joint. Except n fixed. Except this. Except this. Because n fixed, okay, we divide by infinity. That is why we get 0. The rest we get 1. Okay, but distribution factor for B must combine BA and BC. Distribution factor for C must combine CB, CD, and CE. Total must be 1. Total must be 1. Okay, so we do as usual. Okay, using the formula and we get, okay, the distribution factor. Okay, in this case, there will be one FEM, one member got FEM. It is come from member BC. Okay, so we calculate as usual, FEM. Due to W, we use WL squared over 12. 1 negative, 1 positive. This is negative, this is positive. Okay, 1 negative, 1 positive. We apply at B, BC, not AB here. BC. This is B, this is C. Okay, B and C. B and C. Okay, FEMBC, FEMCB here. FEMBC and FEMCB. Okay, this is the FEM. And then we move to table. Okay, we move to table AB. Distribution factor is 0. AB. Distribution factor is 0. BA plus BC. Total this equal to 1. 0.545, 0.545, and 0.455. Total equal to 1. Okay, distribution factor. And then C. C consists of CB, CD, CE. So total CB plus CD plus CE. DFCB, DFCD, DFCE. CB, CD, CE. Total must be 1. Total must be 1. So total this and total this must be 1. Must be 1. And DFDC, DFEC equal to 1 because of pin support. Okay, because pin support, we get 1 because we divide by the same thing. It is KDC divided by KDC. That is why we get 1. Okay, same goes to E. Okay, same goes to E. So we just need to do the same. We just need to do the same. Except for C, because we distribute to 3. Okay, 3 end moment. Okay, CB, CD, DC. Again, so for example, B, B, FEMB. FEMB is negative 135. Negative 1, this negative 135. Joint moment is positive 135. That is why we get 73.6 and 61.4. And the rest we continue. Okay, and then for C, for joint C, we have negative 135 plus this and plus this, total moment at joint C. So we distribute into 3. So it is negative 135 times 0.33. We get negative 44.6, and then negative 135 times 0.298. Okay, we get negative 40.2, and then again negative 135 times 0.372, we get negative 50.2. Okay, so we carry over to A, the factor is 0.5. Okay, the factor is 0.5. Okay, BC, CB carry over by times with 0.5. Okay, C to B, C to D and C to E. C to D and C to E, because the factor is 0. The factors the COF here is 0, COF here is also 0. That is why the column leave blank. Okay, because okay, there's no moment at D and at DC and EC, so we leave like this. Okay, that's the answer, the total moment. Okay, the total moment. So yang ni pun I actually have the video on this. Okay, nanti I give you the link. Okay, and this is the bending moment diagram. Okay, to draw this, okay, just as we have done previously. So for ABBA, it is positive, positive means positive, positive. Okay, for BC, it is negative. CB is positive, positive. Okay, positive direction. And then for CD is negative. CD is negative. CE is also negative. So what we get is, okay, ABBA, positive, positive. This direction and this direction. That's why the point is at this position and at this position. Okay, for BCCB, we got negative, negative. Okay, negative, negative. That's why the point is this point and this point. And then for member CE is negative, negative. Member CE is negative, CE is negative. So that's why this point is located here and it is 0 because of pin support. And CD. Okay, CD is negative, CD is negative, CD is negative here. Okay, this is the point. Okay, this is how we draw the bending moment diagram directly from bending from moment that we get in the table. And the maximum moment here, okay, we can calculate using shear force diagram. Have maximum moment means the shear force diagram has intersection. Okay, the shear force intersection refers to this. Okay, so this is analysis of non-sidesway frame. Non-sidesway frame. Why this frame is called as non-sidesway frame? Because of, okay, there are two condition. One, the frame which is symmetry due to loading and geometry. Okay, this is non-sway frame, no side sway frame. Non-sway frame, we can call it as non-sidesway frame or no sidesway. Okay. And condition number 2, okay, it is properly restrained. Properly restrained frame. Okay, for this frame is non-sidesway frame because of condition number 2. Because of condition number 2. Okay, it is unsymmetry. It is unsymmetry. Okay, it unsymmetry. Due to loading, it is unsymmetry. Due to geometry, it is unsymmetry, but it is properly restrained. Properly restrained means there is restraining force because it is sidesway. Sidesway ni means frame ni dia akan move to the right direction. Itu makna dia sidesway. Okay, sidesway. So properly restrained means there is a restraining force which come from support. In this case, because E is pin will have this restraining force. That is why it is under properly restrained frame. And properly restrained frame means no sidesway. So when there is no sidesway means that we can analyze this frame by only considering loading, external loading. We don't need to include the delta, okay, delta into the analysis. Okay, this is about non-sidesway frame. So this example you can find also in the textbook under chapter number 12. Okay, so I want to skip example number 2 so you can do it by your own. Okay, because I want to move to sidesway frame analysis. Do you have any question yet? Okay, we want to move to this right now. Moment distribution method frame with sidesway. Before I move further, do you have any question? Do you?
So far, no, doctor.
Okay, so we move to frame with sidesway. So please get focused on this because summative 1.3 will be given covering frame with sidesway. Okay, frame with sidesway where we have to include external loading. To calculate FEM, we have to include external loading and we have to include also delta, which is come from sidesway condition of frame. Okay, so let's look at this first. To determine sidesway and internal moment at the joint using moment distribution, we use principle of superposition. Okay, principle of superposition. This is very common principle, okay, in engineering, especially in civil engineering. Okay, you will find this principle of superposition also in flexibility method. Okay, in chapter number 2. Okay, the frame shown is for this is the concept that you need to understand. The frame shown is for help from sidesway by applying an artificial support. Okay, at C. Moment distribution is applied and by static the restraining force, the one that I have mentioned just now, is determined. The equal but opposite restraining force is then applied to the frame. The moment in the frame are calculated. This is just the short summary of the procedure. Okay, so this is actually to represent the concept of frame with sidesway. So focus on the first one first. This is actually frame with sidesway. Why we call this as frame with sidesway? Refer back to two conditions I mentioned to you just now. Okay, kalau frame tu is non-sidesway frame, the frame must be symmetry due to loading and geometry. Okay, by looking at this frame is not symmetry because of loading. This loading is not subjected at the center. If P is subjected at the center, then the frame is non-sidesway frame. But in this case, we can see that the column A, B, and C, D both have same length, same height, but loading is not symmetry. So when loading is not symmetry, okay, this frame is tend to sway, tend to side sway. Okay, tend to side sway. We can assume that it can uh, it move to right direction. Okay, side sway to the right or side sway to the left will be depend on loading. However, in the analysis we can assume whether we want to assume to the right direction or left direction also okay. But careful with the assumption with the direction, because this will give the sign for the FEM. Okay, so yang ni unsymmetry due to loading, it will be called as unsymmetry. Okay, unsymmetry. So this is unsymmetry. Okay, due to loading. Okay, due to loading, it will move sidesway. Okay, we assume that move to right direction, for the amount as this delta. Okay, delta. It is horizontal displacement because okay, the frame will move side sway, means horizontal. We consider horizontal displacement, move side sway. Okay, there is combination of delta and P in one frame. Remember that FEM we calculate based on two conditions. We can have FEM due to loading, and we can have FEM due to delta. Okay, we have FEM due to loading, and we have FEM due to delta. And the difference between this, okay, between beam and frame is when we analyze beam with support settlement, settlement in beam is given in the question. Support settlement is given in the question. So whenever we know the delta value, which come from settlement, we can calculate the FEM value. That's why we can combine FEM. We calculate FEM due to external loading, and then we calculate FEM due to delta. The delta is given, then we can combine FEM, and we can solve the end moment, okay, in the table using only one table, because we can combine FEM. But in frame analysis, can you switch off camera? Thank you, thank you. Because switching the camera will
Sorry, madam.
yeah.
Tekan.
Sorry. Because switching on the camera, dia akan kacau recording. Sorry, eh?
Sorry, kak madam. Kita tekan.
Okay. Okay. Kat mana tadi? Okay. Always remember that FEM we calculate due to two condition. So difference between beam with support settlement, and frame with side sway, the difference is due to delta, because delta in frame, the side sway is in frame is unknown value. This is unknown. This is unknown. The delta is unknown. That's the difference. That's the big difference between beam with support settlement and frame with side sway. Okay, so basically beam with support settlement is direct process. We can get the moment directly, but we cannot have the same. We cannot analyze the same with because under frame with Sidesway analysis, P of course will be given. Okay, external loading always given in the question, but the delta in frame is always unknown. The delta in frame is always unknown, and we don't need to calculate the delta value. We don't need to calculate the delta value. That is why, and when we want to analyze end moment using moment distribution method, okay, for frame, we have to apply what we call as principle of superposition. Okay, principle of superposition. So under principle of superposition, what we need to do is we have to divide. Okay, we have to divide these two FEM. The idea is under frame analysis, we have to divide FEM. One is due to loading, one is due to delta. We have to divide between these two because the delta is unknown. External loading is known value. So that is why we need to divide. That is why we apply principle of superposition. Okay, that is why we apply principle of superposition, because due to external loading, we can calculate FEM directly, but we cannot calculate FEM due to FEM directly. We will analyze FEM due to delta indirectly. Okay, that one I will show to you later. Okay, one is known value, another one is unknown. So this is known value. Known and unknown. Okay, so we have to divide into two. That's why we have here two. Okay, so this is where we have, okay, for this one. Okay, so this will be the delta. Okay, this will be the delta. Delta. Okay, this will be the delta. So we have, nampak tak kat sini? We have divide, okay, divide the FEM. Divide the FEM into two. Okay, so when for the first diagram, okay, let's label the diagram. Okay, let's label the diagram. So this is 1 or A. Okay, this is A diagram, this is B diagram, this is C diagram. We have A, B, C. Okay, so for B diagram, that is where you have to know the two condition of non-sidesway frame. Because in non-sidesway frame, it must be either symmetry or properly restrained. Okay, basically for sidesway frame analysis, it is under second condition. We have to make the original frame as properly restrained frame, because we cannot make it as symmetry because the loading is unsymmetry. So what we can do is we can change, okay, the condition from unrestrained to properly restrained, and from unrestrained, this is unrestrained frame. Okay, yang the first diagram A tu is unrestrained frame. This is called as unrestrained. Restrained refers to a horizontal force. Okay, yang akan jadi wall, yang akan tahan frame tu daripada move to the right direction or left direction. Okay, unrestrained. Unrestrained. Okay, so we have, whenever we remove delta, we have to change unrestrained frame to properly restrained frame. To properly restrained frame. So B ni is properly restrained. Properly restrained. Condition number 2, properly restrained. Properly restrained means there is a horizontal force which is called as restraining force, okay, which come with support. Okay, come with support. So this is artificial support. This is not the real one. This is artificial. Artificial support. Okay, artificial support. So by putting this pin at position C, we know that the frame at A, okay, is tend to move to right direction. When the frame is tend to move to right direction, okay, we have to put support at C. So that dia jadi wall kat situ, it cannot move to right direction. Okay, when the frame is tend to sway to left direction, we have to put support at B so that the frame cannot move to left direction. Okay, and in this case, we are from A, we know that the frame is tend to sway to right direction. Right direction, so kena letak satu wall dekat sini. Okay, representing wall. It can be roller, it can be pin, it can be fixed. Okay, depending on how we put the support. But okay, in this Hibler textbook, it suggests we to put pin support, and we just focus on the restraining force, which is called as R, restraining force. Kalau you nak letak roller, ada certain buku dia letak roller. Tapi dia akan letak roller in this direction lah, so that it will also bring the restraining force. Okay, so restraining force, it is actually CX. By putting this support like this, it is actually CX and CY. But our intention is only to the horizontal force which comes with support. It is called as restraining force. Restraining force. Okay, so by putting this artificial pin support at C, okay, that will give us restraining force. Okay, this B frame is now properly restrained frame. When this is properly restrained frame means there is no delta in this frame. There is no delta in this frame. Dia macam yang tadi punya example. Okay, cuma yang tadi tu dia ada another member. Okay, another horizontal member CE tadi tu. Tapi yang ni tak adalah, just put the artificial support, and with that support, it gives us restraining force. Okay, so this is the number 1. Okay, number 2, because B is not equal to A. B is not equal to A. So we have to have another frame. Okay, another frame, the same frame, but this frame, okay, appears here. Number 1, to neutral back this restraining force. Tadi kan ada restraining force dekat sini. So to get back original condition, because dekat sini there is no R. At diagram A, there is no R, right? Okay, at A there is no R. Sini there is no R. Okay, there is no R. So the idea is, when at diagram B, okay, it has negative R, come with support. So we have to neutralize this back. Okay, means that there will be another R which is opposite. So that this negative R plus positive here, positive R, we get back 0 at diagram A. So that's the idea. So this is actually represent the principle of superposition. Principle of superposition. And of course, you don't need to repeat external loading into diagram C, because in diagram C, we just need delta only, because we will focus diagram C for Sidesway frame analysis. and B, we focus on non-sidesway frame. So we have to have this combination. Okay, one properly restrained frame, where we will calculate FEM due to external loading only, and then we have another frame, okay, where we will calculate FEM due to delta only, So this is actually the principle of superposition. Okay, do you have any question? Do you have any question before we move further?
Not there.
Okay. Okay, we move to this one. Okay, this example. Actually, this is quite straightforward example. Okay, this is quite straightforward example because EI is constant and the length, the geometry, the geometry of the frame is also constant. Okay, tak apa, kita tengok dulu konsep dia. Okay, determine moment at each joint. Remember, moment at each joint, internal moment, member and moment are the same. Okay, are the same. We will calculate this end moment using distribution table. Okay, so actually, okay, it is like this. Okay, it is the same thing. It is like this. So this will be diagram A. This will be diagram A. This will be diagram A, original. Original has combination. By looking at this original, by looking at A, it is unsymmetry due to loading. So due to loading, okay, this is unsymmetry. Loading means that there will be, okay, delta. Okay, this frame will move to side direction. Okay, means that there is delta. Okay, both delta at B and C will be equal, assumed equal. Okay, so move to this one. This is B actually. B. Okay, this is B. Okay, this is B means that due to artificial pin at C, so there will be R here. Okay, R as the restraining force, and due to this, it is now called as properly restrained. Properly restrained. Properly restrained frame. Properly restrained frame. So we have removed delta from this B diagram, so we can start analyze this. Okay, by number one, of course, calculate K, calculate distribution factor, and then we calculate FEM. So FEM for this B diagram, okay, we get from member BC. Here. Okay, we get from member BC, it is 16 subjected. Okay, 1 meter from B, 4 meter from C. So there is a formula to calculate FEM due to this loading. So we get like this. 1 negative, 1 positive as usual because of the behavior of FEM due to external loading. So we get this. Okay, then we put into the table. Since so it is symmetry due to loading, means we get 0.5, 0.5, 0.5, 0.5, because the column, all members has same, okay, same length. So the distribution factor is 0.5 like this. So A and D 0 because it is fixed. Here is, this one is fixed, this one is also fixed. So it is 0, 0.5, 0.5, 0.5, 0. And we put, okay, negative negative 10.24 here and 2.56. Okay, as the first member and moment in the table, and we just need to start this doing okay moment distribution. Yang ni sama macam beam, tak ada beza langsung. Okay, tak ada beza langsung. We just need to start by okay, change to join moment, time with factor, we get 5.12, 5.12, and then 2.56 change to join negative 2.56 times 0.5, we get negative 1.28, we get negative 1.28, carry over because all fixed, so we have to distribute, okay, we have to carry the value, not distribute. We have to carry the value, the factors are all 0.5, all 0.5, and then we continue the process until the moment reaches zero value, 0.0, you may stop. So we get this. Okay, this, okay, the member, the moment in the first table, the moment in the first table refers to diagram B. Okay, diagram B, we can put label as M. Okay, yang ni apa? Yang ni M not. Okay, M not. I like to use M not for the first table. Okay, for the first table. Okay. Okay, move to this. Okay, move it because we will actually differentiate between the first table, label for the first table and label for the second table. So that's why I put M not for the first table. Okay. Then okay. Okay, this is how to calculate R value because the restraining force have to be determined. The restraining force have to be determined. How to determine this restraining force is by using static equilibrium. Okay, we have to apply static equilibrium to calculate R value. To calculate R value. So how to do this later on, I will show to you how to determine this value because R value, you will have two R actually in the analysis. You will have R value and R prime value. Okay, means that we will have to calculate R and R prime two times. The procedure is the same. The procedure is the same except the value of R and R prime will be different because R prime we will get from second table. Okay, so yang ni nanti kita buat perincian dia later lah. So yang ni. Okay, kita nak move to, okay, yang ni yang second table. Second table. Okay. Kita tengok dulu nota ni. Nanti saya akan explain balik. Macam mana nak fahamkan konsep second table ni. Okay. For the second table, okay. Okay, this is diagram C. Diagram C where we have frame, okay, due to restraining force, and due to restraining force, there will be delta. There is no external loading here. We will calculate based on external, based on delta only. Okay, and why we have another diagram, but the label is different. Okay, the label is different. Okay, in diagram C, this is actually the delta, and the delta is unknown. The delta is unknown. And remember I said just now, we don't need to calculate delta value. We don't need to calculate delta value. The delta is unknown. So when the delta is unknown, and this is the real delta actually, can we calculate FEM when delta is unknown? Can we calculate FEM for diagram C when we do not know the delta value? Can we do that? Can we do that? Can we analyze diagram C directly? What do you think?
Yes.
Okay, my question is, okay, we have diagram C. We do not know the delta value. You do not know the delta value. How are we going to determine FEM when we do not know what is the delta? So, can we calculate FEM for C? Can we?
Tak boleh.
Tak boleh ya? Tak boleh. We cannot calculate FEM for diagram C due to unknown delta. Remember that C ni come from original question. Means that the delta here is original value that we do not know. So when we do not know the delta value in C, means that we cannot calculate FEM. Okay, FEM for diagram C. Okay, so what should we do when we do not know the delta value and we cannot calculate FEM value? Okay, here we need to introduce another diagram called as diagram D. Diagram D. Ni, yang sebelah dia tu. Diagram D. Diagram D, okay, diagram D, what we do is, okay, this is another diagram. Okay, we assume the same frame. Nampak tak? Dia sama je. Except the loading, the label, the symbol, kan? We put prime. Okay, we put prime. That is why if we compare C and D, under C we have R. Under D we have R prime. Under C we have delta. Under D we have delta prime. So if what we want is moment in C, the label is M. So in diagram D, what we get? M
Prime.
prime. Yes, M prime. Okay, we introduce another diagram called D. This is assumption. Okay, kalau this is not real, the real one is C. D is not the real one. Can we assume value in C? Can we assume? Can we? Dalam C boleh assume tak? Dalam C boleh assume? Rasa-rasa?
Boleh.
Dalam C tak boleh assume. Tak boleh assume value. Tak boleh assume any value. Because diagram C ni is come from original yang diagram A tadi. Yang kita pisahkan FEM due to loading and due to delta. Means that delta dalam diagram C ni is the real value. Jadi kita tak boleh assume. We cannot calculate FEM and we cannot assume FEM for C. So what we should do is we have to apply, okay, diagram D. Diagram D with, okay, all is same except label tu lah. Geometry semua same. Okay, geometry is same. The label. Okay, if in C we have R, in D we have R prime. If in C we have delta, in D we have delta prime. If in C we have M, in D we have M prime. Okay, these two diagram is proportional. These two diagram, these two frame is proportional. Okay, and we will analyze diagram D, not diagram C. For second table, we will analyze diagram D for second table, not diagram C. Okay, we will analyze diagram D. Okay, so this is artificial. Again, this is assumption. Okay, which we made proportional with C. So we can assume FEM. We can assume FEM in D. Assume FEM in D. assume FEM in D. Again, we don't calculate delta value. We don't calculate delta prime, but we assume FEM. We assume FEM. So yang ni nampak simple. Semua nilai assumption tu 100 because the geometry is same. Because what is actually happen is, okay, what is actually happen here is FEM due to delta, the formula for both and fixed for far and fixed FEM, okay, FEM due to delta is 6EI delta. In this case is delta prime over L. L in this case is 5. Okay, 5 squared. 6EI delta prime over L squared. Okay. What we should do is we will assume FEM for one member and we will calculate FEM for another member using ratio. So if FEM AB and BA, FEM AB and BA, we assume as negative 100. The most important thing here is this sign. Okay, this negative shows the behavior of the frame. This negative shows behavior of the frame. Because look at the frame. So the frame is tend to move to this segitiga, triangular. Okay, from original is vertical. For column, original is vertical. So it moves clockwise. Okay, it rotate clockwise and moment always opposite. Fixed and moment always opposite with the angle. So opposite means this direction. That is why we need to assume negative 100. Because if we put positive 100, it means the frame is moved to left direction. Frame moved to right direction is negative FEM because of the behavior. Triangular. Okay, for beam, of course, beam is horizontal member. So column is a vertical member. Okay, move to right direction means it move in this direction. Okay, so we get triangular like this. Okay, we have triangular like this for both AB and CD. For both AB and CD, okay, it move, okay, from vertical, to new position. Okay, this will be the delta prime. Okay, and always remember that between angle is called as chord rotation. Okay, when angle is positive, okay, means that FEM negative. FEM negative. Okay, means that this frame is moved to right direction. Okay, move a frame is tend to sway to this one means right direction. If frame move in opposite direction means move to left direction, FEM will be opposite. Okay, opposite. So that is why nampak kat sini negative 100. Negative 100. Okay, negative. This sign is very, very important. This sign is very, very important. Okay, this is kilonewton meter. Okay, this is FEM for member AB. We assume as 100. This is assumption. Okay, this is assumption. This is assumption that we made. Okay, this is assumption. And after we have assumed this value, what we need to do is we have to calculate FEM for another members in the frame using ratio, using formula, and it will be based on ratio. Okay, when we apply formula, for FEMCD, so for FEMCD DC, okay, the formula is also 6 EI. EI is constant. Delta is also same. Delta is constant. Length is also same. L is also constant. That is why we get, okay, that is why we get FEM for CD equal to negative 100 as well. Nampak tak dia ratio? Nampak tak? Between these two, dia actually ratio. Dia ada tiga benda yang akan influence dia. Number one yang ni, EI. If EI is not constant, dia akan ubah nilai FEM tu. If delta is not constant also same. If L is not constant, is also it will change the value. So ni ratio dia apa? 1:1 kan? Because ratio sini 1, ratio sini 1, ratio sini 1. That's why you get the same. Okay, that's the idea. Yang ni straightforward. That's why nampak macam straight. You dapat jawapan. Okay, so we use all negative 100 for AB, and we use negative 100 for BC, for CD. BC because of BC is beam, and beam for this type of frame has zero displacement. That is why yang sini zero displacement. There's no vertical displacement. That is why we don't calculate FEM for BC. Okay, so the difference between table 1 and table 2, is only due to FEM value. The process will be the same. That is why kalau you dah boleh set formula dalam Excel, actually you just need to change FEM value. Okay, just change FEM value and you will get the FEM, the end moment for the second table easily. Okay, and okay, we have first table and second table, and for first table and second table, lepas dah dapat end moment from first table and second table, of course we need to calculate R value. Yang tu saya hold sekejap cara nak cari R tu, sebab R tu actually we calculate from static equilibrium. Tapi yang saya nak fokuskan today is about the Sidesway frame, how we can calculate FEM for diagram D. Okay, for diagram D yang tadi tu. Tapi yang ni yang simple because the ratio is 1:1. That is why we get like this. Okay, kita nak tengok kejap lagi example yang we have to calculate. We have to do some calculation in order to get FEM due to Sidesway. Okay, so this will be the process lah. So we calculate R value, and then we calculate R prime value, and then we apply into the formula that we can get from principle of superposition, and finally we get the final end moment. Yang ni lah final end moment. So example ni ada dalam textbook. So detail explanation dia please read from textbook. Okay. Do you have any question? Kita nak tengok another example. This one. Ada soalan apa-apa tak nak tanya before we move? Kejap lagi kita buat satu example yang full punya. Kalau sempat tak sempat nanti saya akan habiskan dalam sesi video lah, recording. I normally do live lecture. Bukan recording. Lepas tu link tu saya akan share dengan you lah. Okay, do you have any question? Ada tak? Nak buat example dulu. Banyak bending, bukan. Moment distribution method ni dalam YouTube paling banyak lecturer overseas, especially from India, yang from India lah yang banyak. From India ada banyak buat. Okay, example how to analyze frame with Sidesway. Not only from India lah, yang kalau negara-negara Mak Saleh pun ada juga. Okay, tapi yang paling banyak from India. Okay, and my video also, saya punya first recording lecture yang saya buat saya dah start buat MDM ni in 2017. Okay, in 2017. Tapi boleh tengok last year, last sem punya video, yang tu lama sangat kan. So yang last sem punya video, you kena tengok lah, you boleh tengok. So yang ni adalah coverage yang ada dalam frame. So frame ni, yang tadi example tegak tu cuma yang basic. Sebab under frame with Sidesway, dalam you punya syllabus, dia cover sekali frame yang ada incline column. Macam ni, C dengan D incline. C dengan D incline. Yang ni pun cover, masuk dalam your coverage. Lepas tu ada satu lagi example in the textbook. Yang ni pun dalam textbook. Yang ni cover dua incline. So yang ni pun under syllabus juga. Okay, that's why saya kata dengan you tadi, 1 minggu memang tak cukup untuk cover. Okay, 1 minggu memang tak cukup untuk cover. Kita cover sekali yang minggu pertama yang kita tak sempat buat tu. Okay, so saya akan, actually saya dah ada solution, full solution semua ni, dan saya akan bagi dalam Teams. Okay, you tengok solution tu, and the most important things, you have to understand the concept lah. Dia sama je principle dia kan dengan analysis of beam. Actually table number 1 tu is exactly the same with what you have done in beam. Tak beza langsung, except R tu kena cari. Yang tu memang new one. Lepas tu for Sidesway frame analysis, actually you have to calculate FEM tu. Yang tu actually your mathematical knowledge. Dia bukan structure kat situ, dia mathematical knowledge. Konsep dia bila you boleh apply K, bila you boleh calculate distribution factor, you can apply the right FEM, you can do moment distribution, semua tu structure. Tapi for Sidesway frame analysis, macam mana nak calculate FEM yang kita assume tu, actually yang tu adalah matematik. Dia PO1 dekat situ. Macam mana kita nak guna ratio untuk identify trigonometry dengan ratio. Dua benda ni. Trigonometry dengan ratio for identifying FEM. Okay, FEM yang kita akan pakai untuk calculate end moment for table number 2. Okay, dua-dua ni under coverage. So yang saya nak buat sekarang is, kalau ada soalan you boleh interrupt. So kita ambil je lah soalan dalam ni. One question. Yang ni pun quite straightforward. Tak nak. Kita create yang baru ya. Kita create yang baru. So yang ni saya add week. So this is week 4. with 4 frame frame with side sway, with side sway. Okay, frame with side sway. So create another one lah. Okay, ni. Okay, so I want to have this frame with the column is not symmetry. Column is not symmetry means the length is not symmetry. Okay. And kita buat satu fix, satu pin. Satu fix, satu pin. So sini pin. Okay. Satu fix, satu pin. So sini ada satu point load. Okay, ada satu point load dekat sini. This is 200. Okay, 200 kilonewton. Kilonewton. Sini ada satu UDL. Okay, this is 60 kilonewton per meter. Okay, so ini A, B, C, and D. A, B, C, and D. So length dia, okay, length ni, this is 4 meter, this is 4 meter, this is 6 meter, 4 meter, 4 meter, 6 meter, and then apa lagi? EI. Okay, EI, okay, EI, kat sini EI, dekat sini 2 EI. Dekat atas ni EI. Okay, like this. Okay, so this is the frame that we are going to analyze. This is the frame that we are going to analyze. So of course, we have to apply principle of superposition. Apply principle of superposition. So we will get by applying the principle of superposition, we have this. We have this. Okay, we have to put support here. Okay, we have to put support here. Okay, like this. Okay, so there will be an imaginary support at C, and with that we have restraining force. This is the restraining force, R. Okay, this is B diagram. So this is A diagram, this is B diagram. Okay, so we have to plus with, so this is equal. Okay, this one you have to plus with, or here. Okay, we have to plus with, okay, the frame without external loading. Okay, without external loading. Okay, so we have R in opposite direction. R in opposite direction. So this R, okay, so this is plus. So like this. So okay, this is C diagram. So we have here the delta. Okay, we have delta. Okay, so this will be the delta. Okay, so end moment. So this is the diagram based on principle of superposition. So, okay, we want to calculate FEM for A. FEM for A, the label is M final. M final, okay. The end moment from table number 1, which is diagram based on diagram B, the end moment that we get from table number 1, we label as M naught. We label as M naught. And then the moment that we get from C is called as M. M is called as M. However, because C, we cannot calculate it directly, so we have to have another diagram which is proportional with C. So we call it as diagram D. Diagram D. And diagram D is the same diagram. Okay, same diagram. But in D, okay, in D, what we have is delta. Delta, we have delta prime. R, we have R prime. M, we have M prime. Okay, so we have D here. This is diagram D. Diagram D. Okay. For the table, table number 1 come from diagram B. This is table number 1. This is table number 1. And table number 2 come from diagram D. Okay. So the idea for having this is to calculate final end moment at A. Okay, from the principle of superposition, we have M final equal to M naught plus M. Okay, we get from A, B, and C. Direct. Okay, M final equal to M naught plus M. Plus M. This is direct. M. But M is unknown. M is unknown. So what next is we have to compare these two. We have to compare these two and using interpolation. Using interpolation. Okay, so we have R and M. We have R and M here. And we have M prime and R prime. Okay, forget about delta and delta prime because we don't need to calculate the value. Okay, R under C we have R and R value we determine from B. So means that under diagram C we will have R value. Okay, under diagram C M is unknown. M is unknown. Okay, under diagram D R prime is known value. And under diagram D, M prime is known value. So we have these four with one unknown, so we can do interpolation. Comparing between C and D. Okay, the interpolation of these two frame is like this. Between M and R, okay, and between M prime and R prime. Interpolation. Interpolation. If we want to calculate M, can we do that? Okay, we move the R to the right side. So we put R divided by R prime as this times with M prime. Okay, time with M prime. So we get the equation. We get the equation. We get the equation where R divided by R prime is called as correction factor. You yang datang from diploma, belajar lagi? Belum Frame. Correction factor. Okay, R divided by R prime is correction factor, is called as correction factor. M prime is n moment from Sidesway frame. And M naught ni is n moment from non-sway frame. Okay, so this value we substitute into this. Substitute M, substitute into, okay, M final. So what we get is M final okay, M final is equal to, this is the concept. Kejap. Okay, do you have any question before we continue? Do you have any question? Semua ni dia ada explain dalam textbook. Dia ada cerita in paragraph lah, in paragraph. Okay, tapi in paragraph ni susah sikit lah nak faham dia apa yang dia buat. So, this is actually what is happening. What is happening. So, kalau beam kita boleh buat direct solution, tapi frame we cannot do direct solution because of the unknown delta. So, we have to do indirect solution. This is what we do. Indirect solution we have to do interpolation between two diagram C and diagram D. Okay, we have to make relationship between M and R and M prime and R prime. So daripada 4 ni ada satu unknown which is M as unknown. M as unknown, then that's why dah dapat yang tu kita substitute balik into the formula that we can get from, because A ni kejap dia dah hang kejap ni. Okay, because the formula is from the principle of superposition to get, dia sama juga macam beam. Beam pun A is equal to B plus C. Kalau analysis of beam, kita ada A juga yang actual. A, lepas tu ada B, lepas tu ada C, sama juga. Satu due to external loading, satu lagi due to delta. Tapi in C dalam beam, kita dapat direct FEM value. That's why dia sama je. A tu sama dengan B plus C. So when we apply into formula, A tu adalah M final, B adalah M naught, C adalah M. Okay, but in this case, M is unknown because delta is unknown. So formula is M final equal to M naught plus M. Tapi M we do not know the value. So how to get M value? Kita kena beralih kepada interpolation between C and D. Interpolation between C and D. So between C and D we get M punya formula. Okay, we get M. We get M from interpolation. So M ni equal to R divided by R prime. R divided by R prime kali dengan M prime. So that R divided by R prime, which is called as correction factor, kali dengan M prime equal to M, kita substitute dalam M final, dalam A tu, dalam M final. That's why we get the equation, the new equation. The new equation. Sekejap saya nak tutup ni dan buka balik. Okay, yang ni boleh start klik ya. Your attendance in your future boleh start. Any question before we continue? try to understand konsep dulu. Example macam dah tak sempat nak cover in 30 minutes. Nanti saya akan buat video untuk cover this example full solution. Full solution. Sekarang ni try to understand konsep so that nanti bila saya buat example solution, you boleh follow. Okay. Ada soalan tak?
So far, no, doctor.
Okay. Whether it is tough or not, you have to try to understand. Okay, you have to try to understand. It is very, very important. This one is very, very important. Nanti as engineer, you akan pakai balik. This concept, this knowledge, you akan apply. Okay, try to understand sikit je yang you nak kena fahamkan pun. Okay, yang paling penting kena faham tu lah macam yang saya explain. Kenapa C kita tak boleh dapat direct. Tapi pada beam dia lain. Pada case frame ni C tak boleh dapat direct. Sebab C tu data is unknown. So M kita tak dapat direct value from C. Tapi kalau from principle of superposition concept, of course A is equal to B plus C. That is why we get M final is equal to M naught plus M. So how to get M? We get from interpolation between C and D. Between C and D tu, dia dah tak mau gerak dah kejap saya cuba ni. Okay, between C and D ni. Okay, between C and D. Okay, between C and D ni kita buat interpolation between C and D. Between C and D because between C and D M prime dapat from table 2. R prime boleh calculate. Okay, R dalam diagram C yang the one that we calculate lepas kita buat table number 1. Yang tu saya belum cover full example kan. Okay, so means that R value yang ada pada diagram B guna pada C. Tapi memang bila kita buat proses dia tu, prosedur dia tu, nanti saya akan summary dia punya prosedur. So prosedur dia buat table number 1 dapat M naught. Lepas dah buat table number 1, kita akan calculate R. Lepas tu buat table number 2. Lepas tu calculate R prime. Actually, bila kita calculate R value from table number 1, we will use it under C. Kita tak pakai dekat A, dekat B tu, kita pakai dekat C. Sebab R pada B and C kan sama kan in opposite direction. So bila nak pakai R tu pakai pada C bila kita buat interpolation ni. Bila kita buat interpolation. That's why dekat C tu saya tanda ni. Dekat ni saya alamak tak tunjuk diagram pula. Okay. Ni. Bila kita buat ni, kita buat interpolation ni. Interpolation. Okay. Interpolation R value yang kita calculate from table 1. Table 1 ni diagram B. Kita tak pakai dia dekat B. Kita pakai dia dekat C. Okey, nampak tak? Kita tak pakai dia dekat B. Kita pakai dia dekat C. Sebab kita nak buat interpolation tu kita perlu nilai C. R dekat C dengan R dekat B is the same thing. In opposite direction. Okey, cuma proses dia saja. Kita buat table 1 calculate R, table 2 calculate R prime. Itu dia punya prosedur. Tapi konsep dia R yang kita akan calculate lepas kita siapkan table 1, kita akan calculate nilai R. So nilai R tu guna pada C. Bila kita nak buat interpolation between diagram C and diagram D. Diagram C and diagram D. So engineering memang macam tu. Ada assumption, ada artificial support, ada principle of superposition. Yang ni you memang kena adapt. Okay, you memang kena adapt. This is the basic frame with Sidesway. Tadi kan saya tunjukkan dia ada juga coverage yang incline column. Satu column incline, dua column incline. Yang ni baru yang basic. Okay. And actually you are very lucky you tak ada final exam. Soalan ni memang final exam punya question. Okay, memang final exam punya question tapi you buat dalam assignment. So please try to understand because this is very very important. As engineer nanti you akan pakai this knowledge. Okay, akan pakai this knowledge. Nanti ada yang di antara you all yang akan jadi professional engineer, of course you akan guna balik this knowledge. My friend, Okay, my friend apply for professional engineer guna movement distribution method dalam dia punya design pelantar minyak. Dia kerja under Hill. Pakai balik ni konsep Sidesway frame analysis ni. Okay, ada banyak lah dia punya application outside yang mana saya tak sempat nak explain dekat you in class. You have to take some time untuk read extra material outside. You kadang-kadang you search kenapa kena belajar moment distribution method. Nanti akan ada jawapan-jawapan. Ada ramai orang yang tanya dan ada ramai orang yang jawab. Basically yang jawab tu adalah practitioner. Dia akan ceritalah bila kita pakai MDM apa semua ni. Bukan saya saja belajar. This is very important topic and very famous topic in the world. Okay, in the world, not in Malaysia, in the world. Okay, buku yang kita refer tu University Oxford pun pakai. Okay, means that yang ni memang you kena tahu. Okay, so memang banyak benda yang bila you go higher and higher, you have to understand lah. You tak boleh macam hafal je lah dan biar cukup dulu saja. Tak boleh macam tu. Memang you kena buat with understanding. Kena buat with understanding. Okay, so kat sini saya dah tunjuk apa yang dalam buku teks explain in words. Okay, they explain in words. So dia ada interpolation dekat sini. Interpolation between C and D. Yang mana C kita cannot direct assume FEM because delta dalam C is the real delta. Macam mana kita nak assume? Jadi kita assume pada D. So that is why at the end dia ada R divided by R prime which we call as correction factor. Means that whatever value that we assume in D doesn't matter sebab dia akan finally ada correction factor yang akan correct the value and everyone will get the same. Okay, cuma dalam buku teks yang kita hibla ni dia cadang nilai dia 100. So you also have to use 100. Tapi bolehlah kalau you nak try buat assume nilai lain kan. At the end you akan dapat the same value. Okay, cuma kalau contoh you nak pakai nilai 10. Kalau dalam moment distribution nanti pendek sangat pula you punya cycle tu. Kalau you pakai 1000, panjang sangat you punya cycle dalam table tu. That's why just nice value is 100. And 100 tu pula kena based on behavior. 100 tu based on behavior. So negatif positif akan refers kepada frame tu punya movement. Kalau frame tu ke kanan, FEM must be negative. Kalau frame tu ke kiri, FEM must be positive. Okay, representing behavior of the frame during sidesway tu. Okay, during sidesway. So yang ni yang kita kena substitute. Kita kena substitute dalam dalam equation. Okay, M final. So kita substitute balik R divided by R prime kali dengan M prime. So kalau saya tak sure you diploma dah belajar ke tak benda ni. Tapi kalau dulu-dulu punya student yang memang belajar frame ni juga dalam diploma punya syllabus. Ramai student diploma memang dia belajar hafal je step. Okay, dia belajar hafal step table 1, table 2. Table 1 kira R, table 2 kira R prime. Okay, lepas tu dia guna satu formula dia N moment equal to yang saya tulis ni, N moment for non-sway frame plus correction factor kali dengan N moment for side-sway frame. So basically student diploma yang belajar benda ni dia hafal yang tu. Tapi as degree student you have to know where it is come from. Kenapa ada N moment from non-sway frame? Kenapa ada N moment from side-sway frame? That is the concept. Okay, so that bila you dah faham this concept, you can apply to all type, okay, of frame with sidesway. Okay, frame with sidesway. Basically dia macam combination of element PO1 dalam ni yang mana nanti kan you nak identify R, you kena pakai static equilibrium. Means that you have to guna baliklah equilibrium equation, macam mana you nak apply, nak calculate reaction in simply supported beam tu kan. So kita apply dalam static equilibrium. Yang tu basic engineering. And then masa you nak calculate calculate FEM for table number 2, yang kita apply adalah basic mathematics, interpolation and trigonometry. Yang tu yang kita akan apply. Which I cannot do it now because it will take another 2-hour session. So nanti dalam minggu ni saya akan bagi the video, okay, the video untuk cover this example soalan ni. Saya akan buat solution, okay, yang ni. Lepas tu saya akan cover jugalah, mungkin ada satu dua lagi video yang akan cover one incline column and one incline column and two incline column for you to do your summative 1.3. Okay, so jangan lupa tengok video yang saya dah share dengan you last week ya, last few days, saya pun tak ingat. Okay, saya rasa last week kot. Last week video yang saya dah cover beam with support settlement, yang tu actually quite straightforward. I believe you should understand. And yang tu untuk your summative 1.2. Okay, summative 1.2. So saya pisahkan jadi 3 kali bagi. So that you tak rasa terbeban nak kena buat 3 benda dalam satu masa. That's why saya pisahkan. Okay, so summative 1.2 nanti saya akan bagi dalam tempoh masa lebih kurang 1 minggu lah. Sebenarnya dia straightforward, sekejap buat 1 hari pun dah boleh siap. Okay, lepas tu another 1 week you have to do summative 1.3. So lebih kurang 1 minggu, 2 minggu lagi lah. So that 30% tu whenever finish, you saya akan terus mark dalam OneNote. So please submit dalam OneNote ya. Please submit dalam OneNote dan submit tu di bawah soalan. Bukan create new page, submit. Tolong submit di bawah soalan so that saya boleh mark easily. Sebab saya tak perlu ambil banyak masa untuk klik your name one by one. Sebab bila you letak jawapan tu di bawah soalan yang saya send, saya akan direct open guna kelas notebook dekat sini dan review student work dan dia akan open file yang saya send. Dia takkan open file yang you create. That's why saya minta you submit tu mesti di bawah pada soalan tu. Lepas dah submit bawah pada soalan, you kena tekan hand in so that nanti kalau saya nak return markah tu boleh return lah. So saya akan letak markah dan return to you lah, so that this 30% you dah boleh dapat. Saya takkan bagilah coursework mark list tu, tak bagi. So you tengok sendiri markah you dekat sini nanti. Okay, and another 10% quiz pun you akan dapat markah direct. So total 40% ni you dah dapat direct lah from when you finish assessment ni. Saya dah mark, saya return, you dah dapat your mark direct. And quiz you akan dapat immediately after you submit 10% submit quiz tu. Okay, so I think that's all for this session. So yang mana yang okay, nanti tolong inform juga kawan-kawan group yang 5B lepas ni yang tak sempat join sesi ni. Saya invite group B sekali join sebab I have to go to IEM campus pula. IEM office Penang. IEM ni Institute of Engineer Malaysia, Penang branch. So saya subcommittee kat situ. We actually have project with them and for my FOP student lah yang akan join for that project. Okay. So if you have any more question, you boleh tanya direct dekat Teams chat, or you boleh tanya juga dekat dalam Teams conversation. Feel free to ask anything. Okay, nanti ada masa insya-Allah saya akan jawab. Okay. So kena spend time according to your SLT. Okay, kena try to understand. Lepas tu ajak kawan-kawan untuk bincang, because by discussion ni you akan understand more lah. And then kenapa kena ada discussion ni, sebab I always believe that Albert Einstein is right whenever he said this. Dia kata macam ni. Dia kata, if you cannot explain it simply, you don't understand it well enough. Maknanya, you nak test you faham ke tak faham, you kena cerita dekat kawan. Kalau bila you explain dekat kawan, kawan tu faham apa yang you explain, maksudnya you pun faham apa yang you belajar hari ni. Okay, so take some time untuk tengok balik video ni. Lepas tu try to understand and try to explain to your friend. Tengok faham, kawan you faham ke tak faham. Okay, if you cannot explain it simply, you don't understand it well enough. Okay, so I think I have to stop right now. So thank you for joining this session today. So nanti pastikan all the video yang saya share tu you tengok. Okay, so target for the best for this 30% coursework. Okay, sebab markah 30% from coursework ni, from assignment akan bantu you a lot. Okay, especially 60% 60% test tu will be harder. Okay, so thank you. So we stop this session with Tasbih, Kifara and Surah Wal As. Okay, thank you very much. Assalamualaikum.